Hello everyone. Today we are going to look at a few functional interfaces defined as part of the JDK. Okay, these functional interfaces, as explained in our previous session, are the bedrock of implementation of the lambdas. And using these lambdas, okay, we can. There are a few functions or implementations that were provided which help us in writing reusable code as much as possible. Okay, so as part of that, we will be going through the Java util function package. Okay, as part of that, we will be looking at the Java util function package, which contains a lot of interfaces. Okay, if we see here, we have binary consumer, binary function, binary operators, and binary predicates, and at the same time some specific consumers like double consumers, which wherein this consumer is of type double. It returns it takes a double value. Similarly, double predicate, which takes a double as a input for the predicate. Okay, similarly we have int consumers, int functions, and various other predicates, supplier, and function, etc. Okay, so today we'll look into the usage of these various functional interfaces that are provided as part of the JDK. Okay, so as we discussed during our last session, okay, functional interfaces are primarily used in reducing the amount of anonymous implementation code as part of the anonymous implementation. Okay, which can reduce the verbosity of the entire code that we write, which is more or less a reusable code. So as part of that, we have functions by functions, consumers by consumers, predicates by predicates, and suppliers. These are some of the major ones which are generic in nature. However, if we go into some specifics, we have the double, int, okay, and long. Okay, so these are some specific functions, okay, that we can see about. So today we will look into the generic ones, and we'll have a close look at the specific functions, specific functional interfaces as well. So if we see here, function is a basic functional interface. Okay, so which is of type function, which takes two object types, generic object types. Okay, and there is an apply function, as we discussed the last time. Apply is the single abstract function that is mentioned as part of the function type. Okay, so when we define the lambda, that lambda will be attributed against this apply function. So when the apply function is invoked, that lambda gets executed. Okay, so if we look at it, we have a compose function wherein we can mention the function that needs to be invoked and whose output should be used as an input to this particular function. Okay, similarly we have end then, wherein which particular uh, which particular function needs to be invoked, okay, by passing the output of this particular function to it. Okay, so this we already discussed yesterday. Sorry, these are a few methods that could be that are provided with the basic implementations, and apply is the abstract method. So if we see here we have written a simple code to pass an array of string and concatenate it and return a single string. Okay, so let us try this method. So if we see here, we have multiple words which are passed on. We are using a reduce function on streams. So this is part of the stream functions, streams API, which we will discuss in a later session. But for now, let us just look at how it is used in a lambda. So a reduce function has been used. okay, which helps in concatenating the strings that are passed to the that are passed in here to the function. Okay, similarly we have a by function, wherein the by function takes in three object types. Okay, two are of input types, okay, and one is of return type. So it takes two inputs and returns a single output. Now if we see, we do not have a compose or and then, sorry, we do not have a compose method in by function, whereas we have an and then, which wherein after applying the by function, the output of it could be passed on to the in as an input to another function, right? Because it cannot be passed on to a by function, because by function requires two inputs. So and then can be used to to invoke a simple function. Okay, so these are the implementations. Okay, now similarly as a function and by function, okay, we have the specific functions as well. Okay, if we look at this, so if we say double to int function, okay, and double to long function, apply as long, which helps in converting an a double value into a long value. Similarly, double to int double value to a int value. Okay, and if we see int function, apply an int value and return any other object type. Okay, similarly we have long function as well, which is of similar type. Similarly double function, right? So these are a few functions which take the respective type as an input and return a different type as output. Okay, in here we have a specificity wherein we are taking the double value and returning the int value. In this way there are quite a lot number of functions that are defined which could be used. Okay, this is a two double function wherein we pass in specific a different object of a different data type and return a double. Okay, so in a similar fashion, along with functions, we have various other types. For example, consumer. Consumer takes in an input, but it doesn't return any output. Okay, um, it processes the code that is provided as part of the consumer, and it doesn't return any value. That's it. Okay, so we can call a consumer, okay, after executing our consumer, because since the consumer doesn't return any value, okay, and the consumer that is passed as part of the end then will be invoked after executing the accept method of the current consumer. Okay, so similarly we have by consumer, by the name, as the name suggests, it takes two inputs and returns one single output. Okay, however in here, since we can pass on these to the subsequent by consumer, okay, since consumer doesn't return any value, so here we use and then, here we use and then and pass on the by consumer function. Okay, so as soon as the accept method of this function is invoked, the accept method of the by consumer that is passed as part of and then is invoked. Okay, similarly we have another thing called predicate. Okay, so let us see what is so a predicate takes an object of any data type and tests against a condition that we provided as part of the uh, lambda, and it will return a boolean output. Okay, so so here if we see, we have a validate name for lambda or predicate, which matches which checks whether the parameter that is passed to this particular lambda matches exactly to characters alone, rather no special characters or numbers in it, or any special characters, right? So if we see here this test method, okay, this particular lambda gets applied to the test method, it gets executed, and the result will be an output, result will be a boolean. Okay, similarly for this predicate, since sometimes we might test multiple conditions, multiple predicates, we can use end method to chain the predicates. At the same time, we can even use or method to chain the predicates. Okay, and we can use negate to apply the not operator on the predicate. Okay, and similarly, we can even use the not operator on the predicate, which is a static method, right? So these are various methods that are provided as part of the predicate. And similarly, we have by predicate, which takes two inputs, and rest all more or less similar as predicate. Okay. Now, when it comes, we have another functional interface, which is a supplier. This supplier has get as an abstract method and nothing else. So this supplier just emits the data of that specific object type. Okay. Now in here, if we see, we are not taking any input in get, because it is used as a generator function. So this particular lambda generates and returns the pi value whenever it is invoked. Okay, so these are a few so apart from this, there is no other function on this supplier. So the lambda that we provide as part of the supplier could be an auto generator by following any specific logic, which will generate the respective value and return it, which yields the respective value or as an output. Okay, so these are the various important functional interfaces that are of generic in nature, which could be used in our day-to-day life of day-to-day coding. Okay, these functional interfaces help us reduce the amount of code that we write. Let us run these implementations and check the outputs. Okay, so it already ran. So if we see here, we have used reduce and concentrate function, which takes in an array of strings and returns a concatenated string. Similarly, if we see area of rectangle takes in length and breadth as in inputs, and it returns the area as an output. Okay. Similarly, transform and print. We This is a consumer which actually takes in a string, okay, and address salute, which is a welcome message. It displays a welcome message. Similarly, a response takes is a by consumer, which takes the name and the message, which is a response. So here we are providing a response message. Okay. Similarly, here we are doing a validation, wherein if we want the validation to be performed on a name which contains only characters with uppercase or lowercase, and we are using this regex to validate it. Okay. And similarly, if we have the space, we could see that it is the response is false as the validation failed, right? So similarly, if we have a by predicate which inputs the value and the regex together to be validated, right? So in here we see that now we want to allow space as part of the text. So we have added space as part of the text, and we could see that it validated to true. Okay. Similarly, pi supplier is a generator function wherein it returns the pi value as an output. Okay, so if we see here, the get method upon invocation returns the pi value. Okay, so we might we might have a few doubts as of where this could be used, where these functional interfaces that are provided by the JDK could be used. So these functional interfaces, the default functional interfaces that are provided, could be primarily used in using another feature which is called streams. So as we mentioned here, right? So we have used an array of stream or arrays. We have converted the strings into stream and then applied reduce upon those streams. So similarly, we have streams concept introduced in JDK 8, using which we can convert a list or an array into a stream and apply transformation and various other terminal operators and intermediate operations on that data, Okay. um, on each and every parameter in sequence, and generate the data transform the data the way we need. Okay, that is another concept which we are going to look at in the subsequent sessions. Okay, so I hope you enjoyed this session. In case you have any queries regarding the functions, consumers, and predicates, or any other function package type, function classes mentioned in function package type, please do message in comment in the section, comment in the video, and we'll try to address those. Yeah. Thank you.